And I'm live. That is pretty cool. And today is 16th of August 2025, Saturday. And in this stream, I have only 5 questions remaining at the 1300 level, and then I would move on to 1400. And so the goal for today's stream is to complete those 1300 level 1300 rated questions. And after that, there are some questions which I was unable to solve at 1000 rating and at 1100 and at 1200, and we will review those questions. So let's just go. That is cool. Shit, there is already someone watching. Okay, that is very small. Tmux kill server. Tmux set. Tmux attach. Target is competitive programming CP and CP31. And the next question 1300 is this. I will start my stopwatch. Hello, how are you? And yep, I will go into the problem solving mode, whatever that is, which means I will read the problem and I will not interact. I would just act as if I am in an actual contest because I'm seeing this problem for the first time, so I want to practice. That is the main thing, right? I have to solve this question as fast as possible and it has to be correct. I want to get this correct when I submit it for the first time. So that is the goal, and with that, let's begin. Share a same cell. Okay, I do not know how to traverse a set in a reverse order in C++. Shit. Yes, of course. Shit, I am stupid. Shit. Okay, makes sense. Shit makes sense, has to be multiset. Okay, I want to get this right in the first try. If that would be cool. If I could get this right in the first try. I'm getting the correct answer locally, and I think this is correct because that is the way the question is asked. Yep, I am traversing it like this, and the way that I'm checking if the first key elements satisfy the condition seems also correct. Okay, I'm using a greedy method for that, and that to me seems like the most efficient way to do this thing. It shouldn't have taken me this long. This is actually very shit. Code forces might actually go down because of this. You see? Yep. Bad timing. Actual bad timing. Shit. Okay, code forces is down right now. And I thought about it, and I would now do some of neat codes roadmap. And since I cannot do anything on code forces right now, I would go through two pointers and stack at least these two, and then we will look at the others, how far we can go. And how is rating system in CP? I heard CP has same rating system as ELO. Yep, as ELO and Glyco. I don't know about Glyco, but it has the same ELO system as a rating system as ELO as in chess. But in chess, you have two players playing, and depending on who wins, their ratings change. Here you have thousands of people competing in a single contest. Should Kakashi Uchiha? Hello, bro. Kakashi is not Uchiha, it is Sasuke, and Itachi Kakashi is Hatake. Kakashi Hatake, not this. And hi, I will join in 10 minutes. That is cool. Thank you. CF down or not? Yep, it is down right now. Yep, it just went. down due to some maintenance things. That is why I will be doing neat codes roadmap. Well, bro, I tried to solve problem before 12:30 and bad gateway happened before it. Yeah, yeah, things happen. I mean, they had the title, like here they had a warning or notice that this will be down. So yeah, this was not random. And I will be solving neat code now. It's cool. Neat code is more educational. Educational in the sense that while I'm trying to solve neat code's roadmap, my main priority is not speed, it is rather, do I understand the solution that I have written? And here, I think I got this right. I'm doing, yeah, I got this one right. And shit, this, maybe this is the one where I saw that. Yes, shit, yes, 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 yes. So I will show you something amazing right now. So I did this, and my solution I thought was very efficient. Even though it is using a couple of for loops, the outer one is necessary. It is like one that you need. And then the second one is also necessary. Second one runs in time complexity n log n. So the total time complexity of the whole thing is n squared log n. And I saw that this is not the most efficient. So I should look at whatever the best solution is. And the best solution is this, where they use sorting. And I guess it was in the problem statement that you do not have to use sorting. Or nope, it was, I guess, in two sums problem statement that you should not use sorting. So this guy is sorts the array and then has a loop through the whole thing, and then another loop, and inside two while statements. But that is not the thing why his solution is efficient. His solution shows efficient because of this line, which is which is fucking crazy. This person has this function calling, and this is at exit function. This function takes in a lambda function or any function, and this function will run when the main program of this program exits. So when this your program ends execution, this function will run, this function body, and this function body is opening an output file stream, and it is accessing this file display runtime.txt, and in that display runtime.txt file, this function is putting 0, so that when this thing runs, after that there is a file called display runtime, in that you append 0. So when you submit your solution, you will see your runtime to be 0, which is crazy. Here the runtime is 8 millisecond. I guess that is because this file is inside this thing. But if you were to add this line outside right here, then I think this should display 100, 0% runtime 0 milliseconds. Let's see, and yeah, see, 0 milliseconds because of this line. Even though my solution is bad, it is sort of like SQL injection. So yeah, this is a hack, and I think maybe lead code might catch this and fix this and start to do something, ban or something for the people who do this. So yeah, but this one is not very efficient. I want to see some efficient solutions for this, which are like genuine. This one seems to be genuine. And from which college? Just a local tier 3 college near my house. I don't even go there. Bro, how to get 6 LP package from the tier 3 in our campus? Companies are not come how? Well, if companies are not coming to you, then you have to go to companies. And if you want to go to companies, you need to have some worth. And for that, you have to study a lot, right? It is no joke. You want people to pay you money, so you have to be worthy. And this solution is more efficient. So let's go through this one. And we can code sorting here because the one that I wrote takes up n square log n time complexity, and sorting is much better than that. So sorting, and then here we have n is the size of the input array. Then vector, where is the target? 3 sum. Okay, they all have to add up to 0. That is the target vector. And then you do sorting. Answer is a vector of vectors. Makes sense. Then you sort the numbers, and then you are iterating from the first one till the third last one, so that when you are at the last one, you have 2 more elements after that. Now, if you are not at the first one and this one, the one that you currently are at, equals to the last one, then continue. If this one, the current one, equals to the last one, then continue, because you do not want repeated solutions. That makes sense, because and since the array is sorted, same numbers will appear like side by side, so you can continue and do not do any of this. And now with k equals n minus 1, that is the last index, you are doing initializing a variable starting from this ith index. And if j greater than I plus 1, that is you are not at the jth index where you started, and the last one is not I, and the j that you are at equals the last one, last j, then continue. That makes sense because you do not want to repeat. And then int element, that is the element that you are looking for. Makes sense. The element that you are looking for is the negative of nums I plus nums j, because you want to make the whole sum 0. So you want something to cancel this out. And while j is lower than k, where k is the second last element, where k is the last element actually, and nums k is greater than element k minus minus, bring k down. Okay, so you are bringing k down from the right. Okay, so k right now points to the largest element. Right, k right now points to the largest element, and then you are seeing if k is distinct from this, and if k is greater than the element that you require, and you are bringing down k, right? And at some point, either you will reach j, or your current k element will be smaller than or equal to element. And now, if you haven't reached j and the element you are at equals to the target element, then you can push back. You have found a solution, and at the end, that is what you do. So how did this benefit? This benefited because you sorted the array, and you can skip looking for solutions which you do not, which are repeating. Like here, you can skip, and you can skip in this line. Makes sense. And then you have an efficient way to look for the right k. Makes sense. Let's copy this. We will implement this. Yo, that is Vim, by the way. Vim is cool. I did sort the array, so that should have helped me in some way. Okay, sort nums dot begin nums dot end. How to sort think I would like to go through everything. Again, store size of nums, and then for int I equals 0, I less than n, I plus plus. And I guess it is easy to tell that the person who wrote that efficient solution is a Codeforces person because n is using n to represent the number of elements in an array. Right? That could also be a coincidence, but anyways, no, I will rename it to something else. Response. Yes, a lot of characters. And then, right, if I, that is, if I'm not at the current element, and if the current element equals the last element, then continue makes sense. And then I need to iterate through the inner loop, for which I will iterate with j and k for int j equals I plus 1. And also, I do not want this to go there. Yep, I plus 1 and j less than. I do not want j to go to the last element, makes sense. And j plus plus. I guess there was a little subtlety in that solution that I just read, because j is going to increase, right? J is going to increase, and essentially what I'm doing is this is bad. This is actually bad. The time complexity is n square, right? Because I am iterating through the whole I. I'm skipping the elements that are same. That is one good thing, but still I'm going through all the I's if they are distinct. And then the part where I'm looking for a good combination for J and K, that also takes n time. So the time complexity is n square, which is better than log n. But can it be improved? Let's first implement this one. Now, if j greater than I plus 1, that is, I'm not at the first element, and a a is nothing. A is nothing. It is nums that you are working with. Or shit, I can actually change this, right? This would not cause any error, because the main thing that defines the function signature is this part, the data type, and not the name of the argument, the name of the parameter, which is there in the definition. And that was cool. And here, all right, and a j equals a j minus 1. If that is true, then continue. And yo, that is a lot of chat. Well, bro, I try to solve problem. Yep, CF is down. How are you? I am amazing. How are you? Oh, you said hello previously. Didn't hello back. My bad. Hello, how are you? Awaz bhai, how are you? Any first year students here? You? I have, and wait, shit, I had this thing up the whole time. That is crazy. I have an opinion. Neat code gives more depth and understanding, while CF just stimulate problem solving muscles and trains you on quick edge cases through do not with the conceptual depth. What do you think? Yep, I think the same way. Neat code and neat code is more like research, theoretical research scientist thing, and lead code is like a young brat who is flexing his muscles. And we need both. We need both. Int k equals n minus 1. And I think this is bad. I could do better than this. But but this is correct. This is like correct, but the time complexity could be improved. Anyways, I should charge my phone. My phone acts as my camera, which is absolutely crazy. Environment features that come with Apple, that like does not make sense. I can use my phone's camera as my webcam, which is amazing. Int I, yes, k minus 1, and my j is moving forward and my k is moving back, and target is going to be negative of ai plus aj. That is what I want my k to be. And now while k is greater than j and a k is greater than target, right? What I would do is k minus minus, and is there anything else? Nope. When I come out of the loop, if k is still greater than j and ak equals target, then I can append this to my solution. Answers or response dot pushback I J K. Wait, what do I have to return? Do I have to return the index or what? I have to return the numbers. Okay. This is AI, this is a J, and this is a K. Cool. Yep. At the end, after all of this, return a response with the wrong spelling. Response. Let's see if it works, at least in the test cases. Tier 3 college. Like, colleges don't matter now that much. My bad. I mean, you should not use the fact that you are in a tier 3 college as an excuse, right? Because that is not going to change. So, what are you going to do? You cannot just say that you are in a tier 3 college and be sad about it and say that time limit exceeded because you are shit. Okay. So, the thing is just work hard. And that is bad. That is very bad. N square. Shit. Shit. Okay. In this thing, I would have sorted the array, and then what am I doing? I'm taking j and k, and this should never have happened because does it make sense? Does it make sense till where j is going? Okay, j is not going there. Okay, when I enter the loop, right, for the first I equals to 0, this thing is not true, so I will go inside, and here I will put my j equals I plus 1. Cool. And then I will see if j is greater than I plus 1, which it would not be for the first case. Then I would put k equals n minus 1, where target equals minus 0, apparently 0 plus 0 negative, that would be minus 0. And while k is greater than j and ak greater than target, which it never is. So this would just exit immediately. But this thing is true. So I will enter this thing and I will append 000 into my response. Makes sense. And then I would go to the second iteration of j, and now j is greater than ai. and ej equals to the last element, I continue. And I do this for every single zero, for every single element, for and we can say that this loop goes for n minus 1 times, and then inside this if statement is also being executed after this n times, and I would keep continuing. So why is it taking this much time? Because the time complexity has risen up to be n square now, and n square shouldn't be bad. N square should be cool. N square should be cool, but it is not. And yes, relative numbers are on. That is cool. N square should not be bad. I mean, it should be, it is expected to be, but it generally is. But in this case, since our problem couldn't be done any better, then n square is fine. N square should be fine, but it is not, which is crazy. Why is n square bad? I mean, it is generally is bad, but no, no, no. This is not, yes, this is not even n square. This is 2n because this j loop only executes once for when I equals 0, and for I equals 1 or 2 or till n minus 1, we will not execute this j loop because we would see that 0 equals 0 and we would continue. So this is not even n square, this is just 2n, 1 for this and once for this when I equals 0. So that is that. What the heck is analyze complexity? Will they ask me for money? They do say n square time complexity, which it is in general case, but not here. That is very helpful. Shit, that is actually cool. Time limit exceeded. My code that I submitted earlier is much worse than, even though it says like 0 second, it is because of the hack. What is, okay. Okay, this is the thing that I submitted earlier, but this is like worse than that because I have a loop going through around n times, and then this is the thing that I'm looking for, and this is sorted. That is one thing, and then inside with target equals this, I am doing this thing. I'm doing this thing, which is an implementation of the two-sum question, two-sum problem. This one, two-sum input array, part 2, where the array is sorted. And in the two-sum implementation, I am saying lj equals int max, and I start iterating from j equals I plus 1 till the second last index, and if this is not equal to lj last j, if this is okay, last j, shit. Before going on to the next value of j, I have an a variable which stores the last value of j, and I'm comparing if this is different from the last value of j. But now I know that you could check if I am at the first j. If I am not at the first j, then check is the current value of j equal to the last value of j, and if it is, then continue. Apparently back then I didn't know that. That is something, okay. But now I do know, and I will not forget. Right? Forget nothing. Remember everything. and then int last equals j plus 1, and what the heck is L? I have L. Should am I comparing T if T is not equal to L? I am covering a lot of edge cases in this one, which doesn't seem good. Okay, I cannot read my own code, which is sad because of things like this. What the heck is TT supposed to be? What is L supposed to be? LJ makes more sense. LJ is last J. L, I should have written LI. LI would have been better. T makes sense. Target. And this habit of naming variables with a single letter comes from a guy named Björn Stroustrup. That is the way he writes code. And I'm reading his book, so that is the habit that I have gotten. And now I cannot even read my own code. Yeah. Back to the question. And now I know that the time complexity of my code in which it is getting time limit exceeded error in this one is 2n, and which is not bad, which is absolutely not bad because I do not have that many zeros. So I do have the option to copy this thing and paste it into ChatGPT, which is not cheating, right? Because this is research. And remember your words and work accordingly. Work accordingly. Yep. But I also feel it is not as transferable to solve real world complexity as the depth you get from lead code problems. It is kind of like playing chess. Yes, it is not directly, it does not directly affect the things that you do on a day-to-day basis, but subconsciously it makes your brain more alert and more active, and you can catch bugs while writing code. You get better at that, right? Because you have to be correct while you are implementing your code in lead code in Codeforces, and you also have to be fast. So that is cool. You have a better eye, you could say. Great for abstract thinking and fluid intelligence. Shit, that is a amazing term. Fluid intelligence, but still very domain specific. Domain is specific only in the sense that it is domain specific, but it does branch out and it helps your brain in general. Like it is like maths, right? You might never use the cosine function or summation, but it helps you become a better problem solver. Codeforces is down. Yep. Codeforces ain't up, bro. Need code better than lead code. I am a complete beginner. Or data structure and algorithm, it is a bit lack. Wait, it is up. No, it is not. It's a lack structure, so concept overlapping over questions. So better to learn all concepts first, since structure. I'm also from tier 2 university, and honestly, I haven't seen a single student doing CF. I mean, okay. For me, the reason that I'm doing this is not because I like it, but because this is very hard. Like only 1% people get a rating of above 2000, and I want to prove to myself that I can do amazing things, and that is why I am doing this. Some trial lead code, and also I'm getting knowledge about data structures and algorithm, but their problem solving is weak and they mostly just copy. Yep. If you were here, you would probably be the best in our class. Lol. Sounds cool. Yep. Need code, and. Need code, and need code is a person who teaches about lead code, problems on lead code. Yes, I can. I will prove to myself that I can do amazing things. And that is like also you can see that it is possible. You can look up David Goggins. He is one of the motivations, one of the things that motivate me. It is actually crazy, the things that you can do. Actually crazy. I copy this and shit, it will not copy because this is in Vim. Control C. Yep. In this code, if and ChatGPT is the best thing if you have a hypothesis and you want to tell that to someone. And if you need actual human help, you can just go to Reddit. Reddit is also amazing. I was struggling with the submission problem and I posted it on Reddit and someone gave me the solution. And when I got the solution, I was very happy. And let me actually show you. I posted the solution right here. This is the one. This I got this from Reddit. This is amazing. Like shit, it took me a couple of days to actually understand what is happening, but this is amazing. This is pretty cool. You can do this. The initial solution that I got has time complexity n square, but this one is much better. It uses sorting. So and login for that, you have to sort one of these functions, and it also uses space, which is 2n, and you can take it as n, and after that it just iterates from array in the array once. So the total time complexity will be n log n, which is much better than n square. Yeah, back to ChatGPT. In this code, if I have as input array, as input vector, a large vector with zeros as the only repeating element, then I believe that the inner J loop will only run once for the length of n, and to be very specific, n minus from 1 till the end, n minus 1, and the outer I loop will not n minus 1 because I'm not going till the last element, so n minus 2 will run for n minus 2 times, yes, for the whole length. But in that, the outer loop simply does the simply executes the continue expression, not command, and jumps to the next iteration. So in the end, the total time complexity would turn out to be something like 2n. Oh, 2n equivalent. Should I learn how you can, okay, how to print that equivalent element is e n for this specific input. Let's see. And what is it? Good thinking. You are analyzing a special case complexity for the threesome. Okay, it knows that this is threesome. Okay, ChatGPT seems to be smart. Walk through what happens when the input is something like this. Yep, n times. Outer loop A, which is this. For I equals 0, the condition does not trigger, so it goes inside. For every letter I, this is true, so continue, and nothing actually happens. The inner loop over J, this thing at J equals to 1, the condition doesn't trigger, it enters the loop, and at every letter J, this continue will be executed, and then inside that for loop, it will only execute once because the last element is equal to 0, which is not greater than target, so this will not execute since this equal to 0 and target is also 0, the condition this is false immediately. So the while loop runs 0 times, then it checks, is this thing true? It is true, so the total time complexity for this while loop is 1, and 000 would be inserted into my answer response array, and then total work, this body executes once, this body executes once. The total time complexity is basically constant. Shit, because you can see call this constant because would you not count this single statement running multiple times? Hmm. Let's see. C++, yes. N multiple continue dot cpp, and the thing that I'm trying to check here is if I have a loop which goes on for a very long time, it's 1e10, 10 is a very big number, I plus plus, and I would also have to be long. If I see, if this is the only thing that I'm continuing, will this take time? And I do not know how to calculate time, how to calculate duration in C++. You can use the chrono, chrono, chrono library, and in that high, okay, standard chrono, high resolution clock now for a start, and for end, and duration is auto end minus start, and then for milliseconds chrono duration cast for chrono call the chrono millisec, okay, call this function chrono duration cast into chrono milliseconds what duration dot count. Okay, so call this on duration, and after the casting has done, call the count function on that. Okay, okay, makes sense. Yo, okay, so start standard chrono high resolution clock. Shit, now end and auto duration end minus start, and auto milliseconds would be equal to standard chrono duration cast into standard chrono milliseconds. Call this function on duration and call the count. Okay, that seems to be correct. Okay, C out would not work. Standard C out. Time taken would be milli, and a new line. Cool. Line plus plus for multi continue not out, and time taken 0, which is crazy. let's say long x equals 0 and x plus equals I. Now, how much time is it going to take? Wait, okay, something is wrong. Something is wrong because my computer is not this good. Yeah, 15 is actually lazy, by the way. Should maybe because I'm not using X, that is why the compiler doesn't even care. If I were to use X, maybe now the compiler would care to run my loop. Okay, okay, something bad is happening because I'm running a loop, this loop. And what is the limit? Because I'm very stupid. Because shit. Okay, okay, because I was like the condition was wrong. Okay, now I have this X variable here and I'm incrementing this X variable every time. I don't need this continue. So I'm doing some operation and let's see how much time that takes. Seems to be fucking instant. No, save it. Okay, okay, okay. Now, okay, it does take time. 997 millisecond. Okay, around that. And if I were to not use my X variable, will it be calculated still? Okay, it is calculated even though I'm not. And now, if I have an empty loop, will the compiler optimize it? No, it does not. And if I have a single continue statement, will the compiler optimize? No, it doesn't. Okay, flags to use to optimize Clang plus plus. How can I optimize Clang plus plus? Okay, there are multiple levels of optimization. I can use O0, no optimization, O1, moderate optimization, O2, most optimizations that do not significantly increase code size or compilation, enables most optimizations that do not significantly increase code size or compilation time. This is a common default for release builds. Okay, because you do not want to increase the code size, that is why you do O2 optimization and O1 for balancing compilation speed and code performance. Okay, compilation speed and code performance. You want good compilation speed for release builds because those builds can take up to GBs. Linux kernel is like 1 or 2 GBs and enables more aggressive optimization than O2, potentially increasing code size and compilation time in pursuit of higher performance. That is fine. So we will use this one and optimizes for code size enabling O2 optimizations and additional size reduction optimizations. Further optimizes for code size. I do not want to optimize for code size. Enables O3 and additional. Okay, O fast. That is what we will use, including those that may violate strict compliance with language standards. Let's go fast. Let's go fucking fast. Client plus plus. O fast. That is 0 actually. Shit, that is O. Go fast for this thing. Go fast is deprecated. Use O3. My bad. Sorry. O3. Fast math. Shit. Fast math for the same behavior or O3 to enable only confining optimizations. Okay. Shit. Okay. It is optimized. It is optimized. Now it is seeing that I'm not actually doing anything inside this loop. So it just skips the thing. Shit, and there is a difference between when I use the continue statement and when I don't use. Okay, now I'm not using the continue statement and the output is almost instant. And when I am using the continue statement, it is also instant. Yeah, not much difference. And what we can actually do, what we can actually fucking do. Shit. Okay, let's do this. Let's go to assembly. Okay. Uh, and this is all experimental stuff. Bro, my Codeforces is down right now. Is the same for you? Yep, there are some maintenance going on Codeforces. That is why I'm doing this research thing right now. And this is amazing. Okay. So I want to see if I have a loop like, let's say, anything. Where is the thing? Multiple continue. If I have a loop like this, continue, right? What does this loop translate to in assembly? Right, we can do that. We can actually see what it translates to in assembly, but maybe not in C++. First, I will write the code in C and then we will convert it into assembly. And in assembly, we will see what is actually happening. So continue loop.c, and inside here, standard. Okay, fine. I'm getting this error right now because my LSP, because of my LSP. My LSP is fine. Don't worry. Int main and for int I equals 0, I less than. Let's say, can I write 1e6? I don't think I can write that because, okay, I can I turn off my LSP? Oh, wait, there should be some command for here. LSP stop. Yep, that is cool. Yeah, just this much. And now we will convert this code into assembly. This file is called continue loop.c. So to do that, clang continue loop.c, output this into continue.s. We can name it anything we want, but then you just have to pass in this thing, capital S. And now you get assembly continue.s, assembly for the whole thing. And it is just 39 lines long. 39 lines is very long. Okay, so here, shit, it has been very long since I did anything in assembly. Okay, so here you have, okay, let me try to explain. You have this section. There is a name for these things which start with a dot and then there is a word. So this part is telling that everything after this comes in the section part. The section of this whole thing after this comes in the text section. And what is the text section, you might ask? That is memory for a process, and in college it is taught that, yep, this thing, process in memory, you have stack at the top, then you have heap, and stack grows from bottom up, heap grows from top down. Then you have a data section which stores static variables, and at the bottom you have program section, and it is also called text section. So it is like crazy. And let me also show you something. If I have a variable, a string or something which I have, whose value I know at compile time, that goes into the data section, and I can actually prove this. Let's say I have a character, not yes, character pointer, my string, which equals hello world. And since my compiler knows that there is a string like this at compile time, my compiler will store this string in the data section. What this means is now when I compile this thing and I go in there, there should be a data section. Uh, in here, I have a string called hello world. And why is the string in the text section? It should be in the data section. Maybe it is not that long. Okay, and I'm not getting any errors because my compiler, my LSP is off. So that is cool. Replace 8, replace 6, replace 9. Yes, let's see if the same thing happens. Now, clang, compile the same thing and continue. And shit, am I optimizing too much? Okay, I guess I should change stuff in the string so that it is not exactly same and the compiler has to create new strings. Clang out uh, clang and continue.s. Right. Now I have a lot of strings, but they are all in the text section. Why are they in the text section? Let's say I have a very long string, all right? A very long string. Not just, yeah, just let's go with that. I have a very long string and continue, go to the thing, and it is still in the text section. And I want to know what, and my best guess is that the compiler is optimizing it, and that is why it is putting the string in the text section. And why is the compiler doing that? Is the text section more accessible than the data section? If that is the case, and that should be the case because you are like most of the time you are fetching instructions from the text section, so it should be faster, but it is only a conceptual thing, and actually they are physically should be equivalent. There should be no hardware level difference in where they are stored. Okay. So my question is, when I am declaring a char pointer in C and giving it some value at the compile time, like let's say char pointer my string equals hello world, and this should what is should be the word, this should this is expected to go to the data section of a process. Yes, process as a static data, as wait, not as, I can change the static data, so that is fine, that is fine, as a static data. But when I convert this into assembly, I see that the compiler is putting this into the text section instead. Why? And yes, this is the text section, but it also has a small subsection, you could call CS string, uh, and the string that we have is a string literal. That is, it has been literally written into the code. And the name of the first string is str. The name of the second one is str1, and the name of the third one is str2. And so, and in the whole code, in the whole assembly code, there is no such thing as my string 2. Assembly does not know that. See, I'm searching here for my string, but I do not see any results because the names of the variables that you choose does not matter. I can call this thing a very large thing. I can give a very large name. The compiler would not say anything. It would not utter any words because the labels that we use for variable names do not matter. So that is cool. And so I'm in a research mode and I would like to write a function in assembly, factorial function, let's say. Factorial function using recursion in assembly. I will try to write it after this, which would be cool, which would be actually cool. Let's see how that goes. Good question. You have got one of those subtle details. Textbook mental model string literally goes there, collides with the real model. How compilers and linkers works. What happens with this char pointer my string when I declare a variable called myString, which is a character pointer which has hello world as its value. It is a string literal, that is the value of this string has been written into the code itself. Then the C standard says string literals have static storage duration. They live for the entire program lifetime. Okay. The compiler must place them in some section of the binary that is read only and makes sense. Read only. I can change the thing if I want later. Yeah, like if I have this, then later in the code I can say my string something 3 equals to b instead. Whatever it is now, it should change to b. So it is not static. The compiler must place them in some section of the binary that is read-only and persistent. Okay, I agree with the persistent part. But read-only does not make sense. Why not? In the data section is modifiable for initialized data. Example like this. Okay, so this will go to the data section. Okay, let's see if that is true. Int x equals 42. And there is a reason why people use the example 42. Secret to the secret to the universe is 42. In Douglas Adams' The Hitchhiker's Guide to the Galaxy, the number 42 is famously presented as the answer to the ultimate question of life, the universe, and everything. And there is a story behind it, and you can read it. It is very cool, and that is why people use the example 42. And now, if I clang, clang, not clang, plus plus, if I do this, hello world, out, my bad. What is the name? Continue loop dot c output to continue dot s and make it an assembly file and nvim. Okay, I should change my key map for this thing. Dot zshrc, which is right here. Source dot zshrc tmux attach TCP, and the one I was at is C++, I guess. Yes, I was in this one. nvim continue.s. Here's the thing, and I do not see the data section. Where is my variable 42? It is right here. Okay, it is being used as a literal. And you can see the compiler is due to some reason very smart and has expressed the same thing in hexadecimal here. 2a should be 42. 2 2a means a is 10 and 2 is 32 at the second place. So yeah, 32 plus 10 is 42. That is cool. Okay, so this one still does not go to the data section. It is stored in here, but the size of there is a limit to the literal number that I can provide in an instruction because there is a size for the instruction itself. This thing has to be stored, has a limit to its size, and some of that space is taken by the instruction itself, some is taken by the argument. So therefore, this thing has a limit to how much it can grow. Therefore, if this were a big thing, then this would be curious. Let's see. Continue.s and okay, where is the number that I was? 9, 9. There were a lot of 9s, but they are not here now. Shit. Is okay, here I am using this number and then I am left shifting the contents of the 8th register left this many times. This code has a lot of things. So I have a question. How can I compile my C program to simple assembly? I am tinkering with assembly right now and I am converting C into assembly, but the compiler has a lot of extra care taking stuff. I I don't I don't want that. How do I tell the compiler to not add that XE code? Up, wait, optimization. Okay, if I do optimize capital O T, okay, okay, that is optimized. That is optimized. I am not even doing anything. Returning. I have my main function here, and then I'm doing this thing. Why do I have this thing? Okay, assembly school, assembly school. Okay, I forgot. Where were we? Yes, why was that thing going into the text section instead of the data section? So now here's the part that looks confusing depending on the compiler and platform. On Linux, DCC strings normally go into read-only data, but read-only is often merged with text segment, the actual machine code, because both are read-only. It reduces the number of memory segments that has segments the loader has to map. Some ABIs, application binary interface, are linker scripts just and linker scripts just map read-only inside text sections. Okay. So the fact that literals go into the data section is not an actual fact. It is like a theoretical thing and actually does not happen. Mhm. What is the thing? Read ELF. Okay. But after linking, okay, C output into test.o. So this thing is this like core dump. This thing slash C, I am supposing, creates an object file because we are calling this O, and then convert this object back into assembly, that is S. Okay, let's I'm actually curious. Let's write a factorial function in assembly to find factorial, a recursive factorial function in assembly to find factorial. That is going to be cool. NVim clear NVim factorial dot s. Okay, so what do I even begin with? Um, okay, okay. GitHub. I have some assembly on my GitHub. I would like to review it. I wrote some assembly stuff for advent of code. I was testing. It was day one of this year's. No, it was 2024. Yes, yes. Part one dot. No, not this. Part one dot s. S. Okay. So a human writes an assembly like this. Dot data, which means I have some stuff in the dot data section. This is very cool. This is very cool. Shit. Okay. So this part is telling that everything after this comes in the dot, like this much stuff comes in the dot data section. You can literally tell the compiler for a you can literally tell the compiler where to put the stuff. So in this model, this one is better. This one is better. This one is not really better. Do not look at the stuff above the heap. Uh, yeah, this is fine. This is fine. Here you can tell the compiler to literally like point out that put this stuff that I have into the dot data section, which is amazing. So I have all of this stuff into the dot data section, which is messed up actually. And then what are these things? Okay, this is a little assembly tutorial, a mini assembly thing. Here, these things, as I remember, are called labels. That is, these are just, you can think of them as variable names. Print digit, these are the names I chose. Array1, array2, print digit, big number. So this is just, these are just names. All right. And then on the right, this thing tells me what type of label this is. That is what kind of data it is going to store. And this thing as keys. Okay, shit, why do I remember this? As key, this thing dot as key tells that this label points to some text in the ASCII notation. So this thing and the Z at the last means that this is zero ended. That is, I am telling the compiler to put the zero itself, the slash zero itself. So the compiler will put the zero at the end of this string, which is being pointed to by this label. These are technically called labels, but you can call them variables. So this variable is storing some ASCII characters which are zero terminated, null terminated, and the string is this thing. And same for this, null terminated R because I want to read some text file because this is the advent of code. In this, my input comes from a text file, so that is why I have to do this. And then this thing, because I have to print something at the end, and when you print something like print f some stuff, hello world, percent d something, then this string that you are providing has to be declared beforehand in assembly. That is why I have whatever things I want to print later in my code, I am declaring them right here at the top. And this size, I must have used this for something, and then numbers to print some numbers, and then array. This thing is cool. This thing says I have a label called array1, and what is the type of it? It is of type skip. What does skip means? Skip means skip this many bytes. And what does this mean? It means that this array1 pointer, you could call it, is pointing to the first location. This array1 thing is pointing to something like this, to the first address of a block of memory which has 4000 bytes, and 4000 bytes means 1000 integers because one integer takes 4 bytes. So in here I am telling the compiler to skip 4000 bytes, and the first byte is going to be pointed by array1, label array1, and array2 also has. So you can also does the same thing. You can say that I'm creating two arrays, array1 and array2, of 1000 integers each. And then at the end, I'm using this thing. Maybe I would like to print something later in the code. For this is for that. And then big number. Okay, big number is also a label which stores a word. And I think on my system, a word is of 32 bytes. So this should be 2 billion. Shit, yes, it is actually 2 billion. A word is the smallest or the default number of bytes with which your system works. And my system, my processor, has registers of 64 bits, and the word size is 32 bits. So the generally accepted, the thing with which my processor is the fastest is 32 bits. And I must be comparing something, initializing something later to be equal to the maximum value of int, which is around 2 billion. I have not like made this to the maximum value possible, but this will work later. So that was the whole thing in the data section. And then the text section. Text section contains the whole code. And in the text section, I have this thing, global main. And what is global main? Global main, this is, I think these things are called declares or something, it declares or something. So this thing is saying that whatever appears next, put everything in the text section of a process, which is this code and text section. And then this label called main, it is make it global. That is, if some external program tries to access main, make my main available to that external program. And why is this needed? Because when the linker runs on the object file for my process, the linker will want to access the main function from my program's object file and link it to the standard library, because at some point I must be using printf. Yep, here I'm using malloc, so I am using standard library functions. Therefore, the object file for my program needs to be linked with the standard library, and that is why I need to make my main global so that it will be accessible by the linker, which links my program with the standard library. So that's cool. And shit, STP, store pointer. Shit, store. Store pair. Shit, STP stands for store pair. I have register 29, which is, I think, the link register. No, register 30 is the link register. Register 29 is the stack pointer, which is points to the top of the stack, and register 30 is used for callbacks. It stores the address of the instruction which called this current function. And this thing, since every register on this is 64 bytes, 64 bytes mean 8, 64 bits means 8 bytes, and I'm storing here 8 bytes of this 30th register and 8 bytes of 29th register onto my stack pointer. That is why I need a space of 16. And since stack grows downwards, I have to first subtract from the stack pointer 16 bytes and then store these two things onto the stack. What this means is that stack is like this. It grows downwards, and I have my stack pointer pointing to this thing, this byte, which is the lowest. And by subtracting 16 from this, when I do minus 16 from this thing, my value will go down and the stack pointer will be pointing to this place. And I have this new extra storage in which the contents of my 29th register and my 30th register will go. And I do not know why I remember all of this. It was few months ago that I wrote assembly. Not even a few months ago. This was. Where is the time? When did I make this commit? Okay, this was in February. It has been some time. So that is the thing. That is this line, and I do not know why I got into assembly all of a sudden. Okay. Okay. Now I will get back to writing the factorial function. I do not need anything in the data section, because instead of printing the thing to the standard output, I can return my function with the answer of my calculation. So that would be cool. So dot text dot global. My main is dot global and align. Yes, I didn't specify anything about align. This align thing, when you are storing stuff in the memory, let's say you store a char, right, a character, it only takes 1 byte. And then let's say you stored an integer, and this would be a better explanation right here. Let's say I have something like this, and since the word size for my processor is 4 bytes, that is 32 bits. Therefore, if when I'm accessing some segment of the memory, if that segment is a multiple of 4, the size of that segment is a multiple of 4 bytes, then the fetching and the storing would be very fast because that is what my processor is built for. But something like a character which only takes 1/4 of 4 bytes, that is only 1 byte to be stored, and then if I were to store after this character an integer, it would be stored like this because I used 1 byte of this first cell, and that left me with 3 bytes remaining in this first cell. And since an integer takes 4 bytes, I have to take 1 byte of this new cell. And now my memory is kind of messed up. So I do not want something like this to happen. I would much prefer that if I am if my memory is divided like this, and if I have stored a character in some part of a byte of a word, then if I'm storing something else which takes more space like a word, then I would like it to be stored at this place instead. And this thing is totally wasted. This is not being used. But anyways, that is fine. That is like fine because I can spare memory, but I cannot spare time, right? I'm doing this to increase execution speed. So I would rather sacrifice space for speed. That is a deal with the devil. Now align 2. And I am aligning it with 2, and somehow, which I do not understand, somehow 2 translates to 2 bytes. Not somehow, this does make sense. This means that if I have something like this, like if this is the distribution for my memory, and I have stored something in the first byte of a block of 4 bytes, this is 4 bytes, and if I have stored a character taking up only 1 byte, then whenever I store an integer, store it at a place which is like a 2 byte difference from the border of the last block of memory. So the next integer would come around here, and this is also not very bad. This is fine. This is also fine because this is half the word size and it is also optimal. And also in this case, I was like wasting 3 bytes of memory, and here I'm only wasting 1 byte. So this is better and this is preferred. That is why we can use align 2 here. And if I were a nice person, I would store my link register and my stack register onto the stack, my stack pointer onto the stack, but nah, I get shit. I would have to because I have to calculate factorial using recursion. So I would have to. Shit, how long was this? This was 250 lines of code, which is actually crazy. There is a lot of comments here. That is fine. So I would have to store my stack pointer and the stuff. STP, that is store pair the contents of the X29 register and the contents of the X30 register, and I do not remember anything that I did in assembly. I would have to heavily reference the stuff that I'm seeing right now. And yes, I do remember what this thing means. This thing means whatever the current value of stack pointer is, subtract from that minus 6, subtract from that 16. I mean, add to the current value of the stack pointer minus 16 so that I get 16 bytes of a new memory to store this, and this exclamation mark at the end means do this subtraction thing before storing these values. That is cool. And now I am cool. I can do anything I want. in registers 0 to 1 or to 3, 4, 5, anything, any register. And okay, let's put, how do I put some value into a register? Add this and this. I'm storing a lot of things. And add this page offset. This is for file opening and printing. Okay, move. I can use move with a literal value. Okay. Move into x0. Let's say we want to find the factorial for 5. Okay. Or yeah, 5 is fine. 5 is fine. Then I would call a function. I guess BL is the thing, and fact. What is fact? Fact is a label which we are going to define here, and the same thing. The same thing has to go here, because at the end I would get back the contents of these two registers doing LDP, I guess, load pair x29 and x30 from the stack pointer, and then add 16. Yes, I think this is correct. And then branch link to x30. This makes sense, I guess. But before that, now I need to see, I'm expecting in this function that the 0th register has the number whose factorial I need to find. And now it is fucking crazy. I need to see if the number is lower than 2, and if it is, then just return 1, and if it is not, then call the factorial function again as a recursive call. Shit, okay, but I forgot. Okay, BL seek, that is cool. Branch link, cool. Seek, which is what I'm doing here, so that is cool. Okay. How am I doing stuff? Inside my main function, when is my main function? Fread buffer accessing individual rows, and I have defined stuff right here, which is cool. What am I doing at the end of it all? Load pair, that is correct. Okay, 16 has to come outside. Okay, I can do that. I am looking for how can I compare stuff. BEQ, which is comparing. I don't understand anything at all, but this is some wizardry shit. Yeah, this is wizardry. Assembly. I have to do BEQ, which is an instruction for checking branch if equal. Hmm, hmm, hmm. Yes. Okay, yes. Now I remember. Compare, this instruction will take in two registers, and yes, depending on that, there is another register called, I think, something like compare register, and this instruction, compare instruction, will take the values in these two registers, W1 and W2, and you could say that I was using X19 to represent the 19th register, or X0 to represent the 0th register, but now I am using W to refer to the first register. Why? Because right now I am not using the whole 64 bits of that register. I am only using a word, and a word is of 32 bits. And I could go lower. I think I could even access the first 8 bits individually. And this compare instruction takes in two values and compares them and changes a flag in another register, which is called, I guess, equal register or something. And then I am branching B is for branching and equal. If the content of these two things are equal, then branch to this thing, end finder, that is here, and this thing stores this shit. Okay, this thing stores the value of W3 register, whatever the value is in W3, at which memory location? This X4 memory location. X4 is a register which has some address of some memory location. So store the contents of W3 at this memory location and move from 1 to 0. That is cool. And then load pair 19 and 20 back onto the stack, back from the stack, and then return. This is cool. Wizardry. Okay, branch link. Do not branch. Just branch. No, fuck you. Return. Yes, return. And now I would like to compare. Before comparing, move into x1, the literal value 1, and CMP compare x0, x1. And if they are equal, if equal, shit. If I have to find the factorial of 1, then just exit with 1. Okay, shit. I can say that the 0th register, yes, that is cool. I can say that the 0th register is going to contain the number whose factorial I want to find, and then the register number 1 is going to contain the factorial itself. And now, if I want to find the factorial for 1, for for 1, then I can just end. I can just end. Yes, I can just return. Now, BEQ, if it is EQ, then branch to end. And what is end? End is end. And what does end do? End just gets back the value that it is stored on the stack for the link register and other strings, and then returns the function, which will go back to wherever it was. And now, if not branch, that means I need to find value of something. Therefore, let's say, okay, this is bad practice. Move F1. My main function will put the value 1 into my register number 1, and the value of the number whose factorial we want to find is in register number 0, and then branch link to the factorial function, and at the end return branch link. After branch link, move into register number 0 the answer, which is now in register number 1, and with the answer in register number 0 I can return. And inside factorial function, I am storing the link register and the stack pointer. The link register and the 30th register is also for something I forgot. It's 30th is the link register, or maybe 29, one of these is the link register. And this function moves number 1, the literal number 1, onto into register number 2, and then compares is the number whose factorial I want to find, which is in register number 0, is it equal to the value in register number 2, which is 1. If it is equal, then end the function. And if it is not, then I would like to multiply. I guess I can just use multiply, and first comes the target. Yes, store into register number 1 the multiplication for register number 1 and register number 0, and then subtract from register number 0 the value 1. and then branch link to factorial function. Shit, if this works in first try, that is going to be cool. If this actually works in first try, what are you doing? So I am writing a code in assembly for factorial, for finding a factorial, which is like just random stuff, experimental research stuff. Playing, I'm playing. It has been too long since I wrote assembly. I think I can actually change the name for the stream. This is not a competitive programming stream anymore. This is a uh, delving into assembly, ARM, AARCH 64-bit assembly. Delving is the right word. Yo. Okay. So I think this should work. This should work. If this works, I will explain this thing. This should work. This should work. This should work. I don't know. Maybe this branch link. Okay, yes. B has a very specific meaning and L has a very specific meaning. Makes sense. Makes sense. B is for branch to this label, and L means whatever the instruction you are currently at, put that instruction's value onto the link register so that whichever function you have called, when that function returns, that knows where to go back to. And I hope this works. Clang factorial.s output out. Okay, so traction is wrong. Invalid operand for instruction. I could actually do add -1. Connect. Okay, makes sense. Makes sense. Makes sense. Yes, yes, yes. Makes sense because when I am subtracting or adding anything, I have to say the first one is the target, and some does not mean anything. I can say add and put the result in register number 2 and add to register number 0, not 2, -1. Add -1 to register number 0 and put the result in register number 2. Clang factorial. Okay. 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 I messed up. I messed up. This is not ending, which is bad. This is not ending. Okay. I messed up at some place. Okay. The worst part about this is that I do not even remember the whole things. Stack pointer store pair is storing these two onto the stack, right? I can skip this part because this is the main function and does not matter. But when I'm calling factorial, I'm linking to the factorial function. Is my link thing working? Okay, bus error. Okay, factorial dot s bus error. Why am I getting a bus error? BL, I can reference BEQ branch if equal. BL, okay, BL is the way we go, okay, makes sense. BL is the way we go, and F open, okay. So where is the F open function? No, shit, F open is a standard library function. That is fine. I have not implemented F open, but standard library has. I have labels, loop 1, loop 2. These are not functions, these are simply loops. And I am branching BNE B, and that is branch if not equal to loop 2. This is branching. That is crazy. Everything is crazy. Then a small printer, printf. I'm looking for a proper function. Yes, something like this. This one starts from here and ends here. Okay, that makes sense. And when I call this function, I am first of all doing this thing, storing 29th and 30th register onto the stack like this, which I am also doing here, the same thing, right? Store pair 29 and 30th onto the stack, but before doing that, subtract minus 16. Yes, before doing that, subtract minus 16. And then I do my stuff, put some values, add some places. Okay, I can do this. Actually, I can do this. Instead of adding minus 1, I can say sub 1, subtract from x0 1 and store it into x0. Makes sense. Makes sense, right? And then this thing, array printer. Because I'm printing an array, I will be calling this again and again. Branch link t. T is also checking something. Less than LD is less than. If this thing is less than 1000, which is the length of our array, then branch to array air print. Okay. Okay, this is actually like kind of beautiful. And this part starting from here till here gets the address of this label, which I have already defined in the data section. That is cool. And then load register W1, load R, store R, load the value at load the value into W1 whose uh, address is stored in 20th register, and then store the value that you got onto the stack. So I am getting stuff from the memory and storing it onto the stack. That makes sense because printf expects the arguments on the stack. So I branch link to printf, then I add 4. Okay, this actually makes sense because I am supposing that x20 20th register has the current has the pointer to the current element in the array that I am printing, and after printing that element I'm just adding 4 to point to the next 4 bytes. Makes sense. And I am adding 19 to I am adding 1 to 19, which I am just incrementing. In 19 I am storing the number of pairs, the number of elements that I have printed. After every time that I print an element, I add 1 to the contents of the 19th register, which I initialized to 0. So at some point, and then I'm comparing 19, the contents of register 19 with 1000, and if 19 is less than, this LT means less than, if the contents of the 19th register are less than 1000, then go back, which means I have not printed the whole thing. And then add to the stack pointer 16 to get some space on the stack, I guess, right? Because I subtracted some space from the stack to work on the stack. Now I'm adding to the stack pointer to make it go back up. And then I'm loading back these values and I am returning. That is cool. Are you in college right now? I am at home right now, but I get the thing. Yes, I am in college, but I do not go to college. And okay, so this is the exact same thing I'm doing here. Branch link to fact, which is this thing. Maybe okay, this comparison could be the thing, right? This comparison could be the thing because this might not be branching off to this thing. I can do this, or actually we just saw branch when less than, but we do not want to branch when less than. Yes, we want to branch when less than 2, branch off to the end, and end just returns. Yes, and I'm subtracting stuff from the 0th register. Let's see if this works. Hmm. Makes sense, does not make it, actually does not make any sense. Mm. Okay, this has to start at 1 and like this, and let's say 5. We want to find factorial for 5. Land and compile. Hmm. Does not work, does not work. Move into the 0th register 5 and move into register number 1, the literal number 1, and then branch off to the factorial function. And now I am at the factorial function and branch link, which means stuff like this. And I don't actually have to do this. Yes, I don't have to do this part because inside the factorial function, I have to because I'm calling the factorial function again and again, and I would like to preserve the link address for the current factorial function and not go into the abyss and never come out. Okay, so then I am comparing the contents of the 0th register, that is the number whose factorial I want to find. And if it is less than 2, right? This is what I'm checking here. Less than. If it is less than 2, then B branch off to the end. And at the end, LDP, load pair, right? Load pair into the 19th and the 29 and 30. And then add 16 to the stack. Okay, my mistake, my mistake. I am absolutely sorry. It has to be like this. It's somewhat like this, right? Yes, it has to be like this. It, and now it should work. Now it should actually work, or maybe not. There is some updates in lazy. And this does not work. Load pair 29th and 30. And okay, 2 hours. The factorial function doesn't work. Okay, this part is correct. Like there cannot be any mistake in this part. Text global main. Yes. If I were to remove this line, I would get error. See, I am getting a linker error because my main function is not global. Uh, global main, that is cool. And in the main function, the first thing I am doing is the thing putting 5 into register 0 and putting 1 into register number 1, then branch link to the factorial function and move into the 0th register the answer that I got in the first register and then return. And let me actually show you something crazy. Let's say 10. So I'm putting 5 into register 0. Then I'm putting 10 into register 1. And then I'm putting whatever the value is in register 1 into register 0. And then I am returning. Nothing is special. And then call the factorial, right? And then if I were to do dollar, shit, that is not the thing. Uh, echo dollar question mark. See, I see 10. 10 is the value with which the function that I just called returned. Okay. Dot s. Okay, my bad. That is not factorial dot s. So yeah, this thing echo dollar question mark return gives me the value with which the last function which was executed exited, and this function exited with the value 10. And why? Because I gave it 10. Let's say I give it 7, it will exit with 7. But if I were to call this function again, I will not see 10 because now the last function that I executed is not out, it is echo, and I should see 1 or 0. 0 means no error. 0 means no error. If your function exits with 0, it means no error. So that is cool. And now this, and see, this is red. This thing is red because my function, this dot out function, exited with a non-zero value, and a non-zero value is used to represent that your function exited with some error. Now it is 7. But if I make this a 0, and 0 is considered to be good, and now if I see, first of all, I can see that there is no red, so my function exited completely fine with no errors, and that is 0. So cool. That is not the problem. The problem is when I do branch link to the factorial function, das funktioniert nicht. Store pair 29 and 30 onto the stack. So there is some mistake with this factorial function. Somehow, this condition is never being true. This 0th register is never getting less than the value 2. Even though I am multiplying the contents of register 1 with the contents of register 1 with the contents of register 0 and storing them into register 1. Here I am storing into register 1 by multiplying the contents of register 1 and register 0. My shit, I am very stupid. My charger was not charging my phone, and now my laptop is also on low battery. So I should first charge my laptop. My bad. And now we will write the factorial function. And then I'm subtracting from register 0 the value just 1. I'm subtracting 1 from register 0, and then I'm calling the branch function, factorial function again. And now in the second iteration, 0 should have 4, and 4 is not less. So we go there. Let's say I call this with value which is less than 2. And if it is less than 2 initially, then I go there. I'm sub yeah, this is what this should work. This should work. Ah, and factorial dot s not plus plus factorial out. If I run it, okay, there is some error. S funktioniert nicht due to some reason. It does not work. Store pointer, store pairs. Okay, I would have to ask ChatGPT. No, 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 no. I can reference the things I have written in the past. End finder, replace wall, store, load, store. Shit. Okay. Okay, okay, okay. I think I get it. I think I no, no, this is fine. 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 Yeah. Yep. This is fine. Because let's say the 29th register is the link register, and therefore it has the address of the last instruction which linked to this function, right? And if it is our main function which did this branch link thing, the 29th register will have the address for this instruction, which is going to be executed when my factorial function exits, when my factorial function here returns. So since I want to go back to this instruction whose address is in the 29th register, I am storing this onto the stack. And then later, since I'm calling new functions, those calling those functions will overwrite whatever the current value is in the 29th register. Therefore, I am storing it beforehand onto the stack. And then when I am done with my function body, I load back from the stack the values for the 29th and the 30th register. And now, since I now have the value of the instruction, the address of the instruction which called this function, I can return to it. Return function just return instruction returns to the instruction to whatever address is in the 29th register. And this should work, but it is not working. Well, At I think I should have assembly stored, some assembly in some place. No, I do not have any assembly code. Nope, nothing. Tmux attach. Where am I even writing all of this? It is in this thing, C++. Okay. Branch link doesn't work, doesn't work. The thing is it not, can I check if it is not linking to this thing? Compare 0, 0, I am doing something with, but here I am only using the word part of this thing and not the full register. I could also use BEQ. Okay, let's use BEQ with, let's say 5. All right, I have 5 here, and someone calls this function with 5, and then I am comparing 5 with 5, and if equal, then go to the end. Now, at least the least that I'm expecting is for this function to end, which it does not. It does not end. It does not end. Does not end. BLEQ. Should I do BLEQ? B less than branch link less than. There is in my downloads, not my history, in my downloads, control C, downloads. This is the thing. Yeah, this is the book. Yesterday, a friend of mine called me and he asked me if there is some book from which he can learn assembly, and I recommended this one. Load, store, branch instructions. Yep. CV components, registers, load, store instructions, branch instructions, page number 70. Let's go there. Okay, I'm at the end of the file, which is bad. Okay, somewhere around here. This is cool. STP store pair, that is what I'm doing. And then load pair back, and then 30 is the link register. Okay, shit. Do I have to? Okay, shit. I genuinely expected this one to stop. Shit. Okay, it didn't, and that is fine. Mm, Program code, yes. Whenever a function is called, do this. Store pair of registers, register 29 and 30 onto the stack with this division and load them back. Return from subroutine to address in register 13. Subroutine is just a function, an archaic name for a function. Restore values of register 29 and 30 from the stack. See, okay, I didn't have to use return x30 because return x30 is the same as just return, and branch link to register PLR, target address. And okay, so okay, that makes sense. That makes sense. If I'm using branch link instruction, I just provide the target address like I'm doing in this case. But if the target address is in some register, then I have to provide the register. Makes sense. Printf hello world, the equivalent of this much code is this thing. So in the section, The section is read. Oh, okay, I can just say text. Yeah, I can just say text. That is fine. I don't have to say section text. Text and then store pointer is this. And then load into register 0 the address of the first character of hello, and then branch link to the printf function, and then move 0 into the 0th register, get back the values of these two things, and then return. Okay, so let's do this thing. Store pair x29 and x30 stack by getting some 16 bytes, and then at the end, before returning, shit, I am stupid. Shit, that makes sense. That was the thing. That was the thing. I think that was the thing that I was messing up with. SP hash 16 and 16, and now shit. If this works now, it would be cool. This works. It would be cool. Let's see. It does work. Fuck you. Okay, it does work. It does work. It does work. And the thing is, I can actually remove this and this if if I put my main here. I think I can put my main later. Yep, I can put my main later, because then I would just go here and make sense. I don't even have to return. I can call this with 5 and say this is 1, and I should exit with the value of the factorial now. Illegal hardware instruction. That makes sense. Illegal hardware instruction. Of course, illegal. Totally illegal. Store pair x29 and x30 onto the stack with some extra memory of 16 bytes right now. And then before exiting, load the values for those two registers back from the stack and add 16 to it, and then return. Okay, and this should not be at least illegal. Okay, it doesn't. And to see, I called this function to find the factorial for 5, and the factorial for 5 is 120. It is 120, and therefore when I do this and enter, I should see 120. Okay, so yeah, that is cool. That is cool. 120. So this is code in ARM assembly to find factorial for something. And now, can I optimize this? Can I optimize some assembly code? And if I and you would see that if I were to write this code in C for calculating a factorial and compile it into assembly and compare my code with the compiler's code, mine would be more optimized, because the compiler has to take care of a lot of things so that errors don't happen. But I am not doing that. I'm just being careless. Let's actually print this on the screen. Read only data. And let's say label. I have to give a label, right? Uh, Data. No. The label would be string, this thing contains dot as keys, and the thing is factorial, right? Right, and then the text section. Okay, cool. And then here I have gotten the answer in register number 0. Actually, this thing, and I think I have to put this on the stack. Okay, I need some memory on the stack, which I can get sp, no, subtract and store into sp the value of sp minus how much memory do I need to 32. Just blowing up my space, not move, and then add to go back to where I was. And then once I have gotten the thing, I have to get the address of the string at some location. Shit, how do I do that? I was printing some stuff at some point. Yep. Address page. Get the address of page for a labels page, and then add to that the page offset. Makes sense? Makes sense. Okay. So here, after moving this, where would I like to store the address? I would like to store the address in register number 1. So dpr adrp get the address in register 1 for string add page, and then add to register 1 string page of, I think that is correct. Page off, and then now I need to push this onto the stack, and I do have memory on the stack. I got the memory here when I subtracted 32 bytes from the stack, and now I need to push this, for which ldr load the contents of the first register onto the stack, right? Right, makes sense. And branch link to printf, and then get back the memory to thumb. Okay. 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 Uh, Not read only, but unexpected directive. Is that not how you section? Okay, that is fine. That is fine. And do we see the thing? Nope. We see a segmentation fault. So how do we print stuff? How do we print? Printf? Yes. Okay. The thing that I want to print, put it on the stack. Does it make sense? Okay. First, let's try to print hello world, or just factorial. Mhm. Get address of page in register 1. Then add to that page address the page offset for this string label that we want to print. Then load it onto, okay, what am I doing here? Print digit to print a digit. Okay, okay. Its address is here. Okay, that makes sense. That makes sense. That makes sense. And I'm putting onto the stack the current value. Okay, I did the things the opposite way. In the zeroth register, I have to get the address of the string which I want to store, and onto the stack I have to put the actual factorial %d, and okay, now I have page address and register number 1, which I have to put into register number 0, but register 0 has my factorial, so I would move that on to register 2 and move into register 0 the address of the string that I want to print, and then call the printf function, because in register 0 I already have this address for this string, and I have already stored onto the stack the factorial. Now everything should work, and because if it doesn't, then I could cry. Okay, this is cool. Factorial is minus 16. Minus 16. Yes, amazing. Fucking amazing. Minus 16. Okay, and also new line. Factorial is minus 16, right? That makes a lot of sense. Minus 16 is the factorial. Shit. Makes sense. Makes sense. Makes so much sense. Because makes sense. Because I have a digit here, and a digit is an integer which takes up 4 bytes. And here I am storing 8 bytes onto the stack on this place. So instead, I should just store the first 4 bytes. And now, minus 16. Therefore. Okay, shit. Okay, if I do this for my calculations, I will just use an integer. For this, 1 has to be used. Yes, makes sense. For this, 1 has to be used. And then I'm getting the address in 1, and then W makes sense. And W, uh, 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 why am I getting value of 1 here? Because, yes, yes, W, uh, uh, W, and also do the same things here. Just compare uh, an integer words of data. Okay, that should work. Minus 16 is not a factorial, brother. No. Let's see with what value this function is exiting. Right? It exits with 168. That is definitely not the factorial. Okay, I would like to clean the register first. Clean it and then move into the lower 4 bytes, the number 5. Clean the register. And then work with this. Put W1 makes sense, then branch link to the factorial, which I will check in a minute. And then move W0, W1, W contents of W1, which I expect. W1 should have the answer, which I am putting into W0. Actually, I can skip this, and Instead, here use W0 directly, yes, which contains the address of the string that I want to print. And then load the value of this thing. Shit, this has to change. LDR. LDR. Hmm. Hmm. LDR is fine. Hmm. Okay, fuck. I'm stupid. Why am I doing LDR? LDR is for load. I have to store onto the stack. Shit. Okay. Then one has the value. Correct answer. And move from register number 1 into register number 0. The correct answer, and then exit. Yes, this should work. Does. It does work. Let's say I want to find the factorial of 10. Okay, I don't know what the factorial of 10 is, but this thing knows. That is the factorial of 10, apparently. So that is very cool. That is pretty cool. We can write code in assembly. Okay, is there something else that I would like to do in assembly right now? This much is kind of like peak, not peak. I did advent of code in assembly, which is absolutely fucking crazy. The fact that someone shit. There is also part 2 for the second part, which is actually shorter. That is just how you do as advent of code. This is cool. This is cool. Is there something else that I would like to do, or a little program maybe someone from the chat could suggest, which I would write? Is there a program, a little program for like factorial or something similar, simple thing which I could write in assembly? That would be cool to test it out. There are 3 people watching. Maybe someone can suggest something, and there are now 7 people watching. And if someone can suggest a small program like calculating a factorial or something, then we would write that in assembly, in ARM assembly. And if there are any suggestions, then you could send them in the chat. And please be like, uh, my assembly is not that good. Please suggest some simple programs like factorial, or I don't know, simple programs like saying printing hello world on the screen or something like that. That would be cool. Or instead, you could be silent, the 5 people watching. Okay, it's been 2 hours and 43 minutes. That is cool. And what else can I write in assembly? I can ask ChatGPT to some help. Check a number if it is even or odd. Okay, Tony Stark, let's do that. Okay, but okay, if I am hard coding the number like I was here, where I am writing, like I was here when I am writing, find the factorial for 10 right here in the code itself as a literal, that would be easy. But if I'm taking the input from standard input using scanf, That would be challenging. So let's actually do that. Is even odd dot s, and again the whole thing dot data. In the dot data section we have, let's say, yes, even. This will store as keys, and it will say even with a new line, and then we have a string to print when we are printing odd. Okay, that is cool. Even odd. And is there something we would like to? Yes. When we are taking input, okay, when we are taking input, we have to pass into the scanf function this thing, a digit, and then okay, then we can move on. Global, make main global and align. Okay, we can skip this. This is fine. In the main function, all right. As good human beings, we should store x29 and x30 onto the stack by making space on the stack using this thing, and at the end we would load them back in the link register and the other register. Wait, this has to be -16 because stack grows downwards. So when you subtract from the stack, you get memory, and when you add to the stack, you lose memory. And then return. Okay, and here now I have to get an input from the user. Shit, there was this thing, uh, which calling scanf in assembly AARCH64 ARM Apple Silicon ARM. Like there is a website which I do not remember, where you can just go and see which registers are used for what thing. This is the ARM documentation, the literal thing. Okay, scanf. This is the thing, and why does this thing look like it is written in brainfuck, which is an actual language? You can look it up. Okay, so why are ARM developers writing C code? Why are they not writing assembly? Stack Overflow. All right. Get the string, load, and where. Okay, that is the question. I want to see the answer. And right, oh, these instructions being in capital case is messing up. And then branch link, read from keyboard. Okay, read from keyboard. This function, okay, is storing stuff onto the stack. Then getting input format makes sense. And in the 11th register, you are getting number thing, and then calling the function. Okay, what is number? Number is just a 32-bit thing. Okay, that makes sense. That actually sense makes sense. Okay, so scanf function wants me to give the address of the string in the 0th register, and onto the stack the address of the address in on heap, no, from the data section of the place where scanf would store the number. Makes sense. So number, this is going to be a word. That's it. A word, one word, one word, because one word is 32. So a word, would work. A single word would work. Word 32, I think one would work. 32 doesn't 32 mean you are getting 32 words? We will try, we will go with one. And now in the zeroth register, I have to get the string, the address of the input string, which is this one. Shit, I am somewhere off. Right, cool. And here, okay, now I want yeah, ADRP, get address of page into register 0 from input page, and add to that input page offset. Now I have the input string. Now I need to get the address of the number onto the stack, for which LDR load. Before loading the contents of the register, I have to store LDR. Yes, LDR makes sense. In register number 1, let's say I will get whatever is the page address. Yes, page address ADRP into register number 1, numbers page address, and then add into register number 1 the page offset, right? And I would like to store this str contents of register number 1 onto the stack, right? And yep, get some space on the stack beforehand and do this. Now I can branch link to scanf, makes sense. And after coming from the scanf, I have the number in the number variable here, whose address could actually be gone. Okay, right. Now I have in back, I have the number, right, right, right. And now I would like to actually print the number, and my phone's battery is pretty low. So I would also like to recharge my phone. Okay. Yep. Is my camera like working and all? Yep, it is working. That is cool. And yep, GCD. That would be crazy. C off. No, C would be. Nah, I'm not used. It has been quite long since I wrote assembly. But I guess yeah, I can make a dedicated stream on assembly, and in which I can GCD is easy using Euclid's method. Sieve. Can I write sieve? I can, and it would be really fun. Okay, I will make a dedicated stream. I will do a dedicated stream on the sieve algorithm. That would be pretty cool. Writing sieve in assembly. Okay, that is clickbait. Here, after I have this, what do I want to do? Uh, yeah, okay. Add one page offset, but also get the stuff from there, and store one Hmm. That is bad. I have to pro yes, yes, yes. No, shit. Okay, 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 okay. Now I will get the number that I got from there and I will load LDR, load into register number 2, whatever the value is at the memory location whose location is stored in register number 1. Now I have in register number 2 the input variable that I got from the user. And now I need to check it if it is even or odd. Shit, how do I check it if it is even or odd? By taking its AND with 1. By taking its AND with 1. And if it turns out to be 1, how can I check the last bit? There must be a compare function for that. No, I can take its AND with 1, complete and if the number turns out to be, and then I can compare it with 0. If it is 0, then 0, and if it is 1, then it was odd. Makes sense. So how do I take AND? Do I just do AND? I think no. Am I taking AND anywhere here? Okay, at some locations. Nope, AND. Okay, so store into fifth register the AND of this and this. That is bit masking. That is bit masking. That is bit masking. I am getting the last 8 bytes. 8 bits? Yeah, 8 bits. 4 because of this, 4 because of this. That is cool. 8 bits, that is just 1 byte, a single byte. I'm getting a byte. Okay, and store the AND into register number 2. Take the AND of the contents of register number 2, which has the number which was inputted by the user. Take its AND with 1. And now compare contents of register number 2 with 0 and branch if equal to even. Hmm. And if not even, then odd. Then I would like to print odd and then exit. Makes sense. Now how do I print odd? To print odd, I need to first get the address of the string. I'll do that in the 0th register, and I think I have missed something. Nah, it is fine. It is fine. So in the 0th address, ADRP 0th register, get odd page address for odd and add in 0 0 odd page offset. And now I need to print this, which I can just do bl do printf branch link to printf, and now end b branch of to end. And what is the end? This is the end. And here I can define even would get the page address for even and print that even no, it, no. Actually, let me show you something crazy. You can do Control R, and now if I print it, okay, Control R is not capital R. Okay, my bad. Press capital R, and now whatever I print is going to rewrite whatever was there. So that is cool. Capital R, and I have to write N, which is even takes more space than this. Then odd. Okay, now should this thing work? It should. This should not, because yes, because I did this thing on the stack. I got some extra space on the stack, so I would like to give it back. I would like to give it back. For that, add to stack pointer 8. Yes, lang, not factorial, lang is even odd. It at least compiles even not shit. Okay, I got an error even before this thing. So I was storing this much. This is correct. Then I'm getting address for input, which is defined above. Input, get stuff for input, and input page offset, add the page offset. Then address one, get number page. Maybe I just have to do something like this into register number one. Get this, and then onto the stack. Put it onto the stack. Let's say I need more space. Okay. Let's say I am using more space, then I would have to return more space when I am done. And if that is the error, let's see. Okay, it is waiting for a number, I guess. 7. 7 is odd. Okay, 7 apparently seems to be odd. 2 seems to be even. And before exiting, move into register 0, 0, like this 0. Okay, what about 5? I don't know. 5 is odd, apparently. What about something like 10? 10 is even. Okay. Something like now this. Okay, that is odd. Okay. And if I do 2, that is even. So that is cool. That is cool. That is very cool. Glad to hear it. Sub cool. That is very cool. Thank you. This is amazing. This is actually pretty cool. Is even odd. Okay, so this is the whole thing. You can look at it in one view. Okay. And is there something else? Do you think you will get a specialist in next contest? Yes. Yes, my rating is 1363 or 65. And yes, I hope at least if everything goes fine, I will get specialist. Yeah, I will be a specialist. But I am hoping because it is division 3, right? Is Codeforces still down? I think it is division 3, and in division 3 I want to get a rank around 1000 or below 1000. 3-digit rank, that would be nice. A 3-digit rank would be really nice, and if I could get that, I would become a specialist, which would be cool. I'm expecting, not expecting, I have not actually given the contest, but I want to do that. How much time have you given coding? I try to I try to waste as little time as I can, not coding. And if I were to quantify a thing, then I sleep, I eat, I do some exercise. And for coding specifically, there is in coding, there is the writing part, and there is the studying part. There is actual writing code, and then there is the studying part. So in total combined, around 10 hours would be a good estimate. Implementing printf, scanf in assembly from scratch could be a fun video too. That is going to be crazy, because to do that, you'd have to call syscalls, make syscalls to the operating system, and operating system would put stuff onto the terminal, which is yeah, it is hard. It is hard because you have to make manually make syscalls. And yes, I am a college student, unfortunately. This is cool. Assembly is cool. Assembly is cool. And this advent of code question that I did in assembly, this one spans, wait, the part one, this thing spans 250 lines. And this is not even pure assembly because inside this, I am using library functions given to me by standard library functions like printf, right? But if I were to implement my own printf and scanf, shit, because this is advent of code, I am reading input from a file. And I write here fopen. I'm calling fopen to get it to, and then fseek, and then ftil, and then rewind, and then malloc some space to get file, and then fread. That is crazy. And then yeah, this is the code part. But till now, all of this thing is just to read the contents of a file. All of this is to read the contents of a file, and this is not even pure assembly. Here I am using external library functions fopen, fseek, rewind, malloc, fread. I'm not even making syscalls. These functions are making syscalls for me. And still it is this long just to simply read a file. So that is assembly. Syscalls are just three instructions. Uh, Syscalls, a syscall has to have a number, like this syscall ID, the instruction to call the syscall, to make the syscall, and I would have to review how to make a syscall. All of this is crazy, by the way. And it has been 3 hours and 6 minutes. And is there anything else I can do in Codeforces stream turned into assembly stream? I don't know if there is some suggestion. Maybe we can see. There is this one thing that I have been trying to do recently, this math thing, which apparently improves mental math, this maths quiz. And yeah, I will not take this quiz like live. Yesterday I took this live and it was embarrassing, very embarrassing. I was not able to answer questions. But what I can do, see, geography quiz, I'm not even up to the mark to to take some geography. But I can do, I guess, Wordle for the day. Yeah. And after doing the Wordle for the day, I would end the stream. That would be cool. Let's see the Wordle. Which country is this? This Burkina Faso? Okay, it is not very close to Burkina Faso. Which country is this? Not Iran, Iraq. This is to the east of Burkina Faso. And is this on the African mainland? 7,000 kilometers. I guess, is it Cambodia? No. Okay, it is top. Is this Switzerland? No, but not even close. To the right. This is not Ukraine. Wait, what? This is not Ukraine. To the east of Switzerland, something like this. Is it is it Kyrgyzstan or something? No, shit. This could be, wait, is this Afghanistan? Fuck yeah, okay, it is Afghanistan, my bad. I should have known that. And the neighbors that Afghanistan has are China, right? Pakistan, Iran also, yeah. And on the north, there is Turkmenistan, Turkmenistan, and I would suppose Azerbaijan or it is, does it also touch Iran, share border with Iran? Uh, Azerbaijan? Okay, Azerbaijan is not there. Afghanistan touches this, and what are these two countries? This this thing is strange. Okay, Azerbaijan. Nope, this is not Azerbaijan. Any suggestions? Some help? If you are a college student, are you a minor? No, I am major. I am 21 years old. And do you read the live chats? Yep, I do. And now I'm struggling with this one. Which country is this? This is one of the neighbors of Afghanistan. Okay, which countries are there? On the north, we have Turkmenistan. Turkmenistan is done. This is one of the smaller countries, or Iraq, Iran. Iraq, no, Iraq is not even close. Iran, none of this seem like. Oh shit, Iran is already done. Afghanistan apparently doesn't mm, share any border with India, and Azerbaijan. And what are the other countries there? There is Georgia, and there is one more country in the Caucasus. Let's try Georgia. Georgia is also not the answer. There is one more country there. Uh, Azerbaijan, Georgia, Armenia. Armenia is also not the answer. My bad. Okay, last try. One of these is a neighbor of Afghanistan. Shit. I mean, both of these are. Why do I not know this? Turkmenistan, does it also share border with Tajikistan, maybe? Okay, okay, apparently it does. And the last one, let's say. Then Kyrgyzstan. Okay, Uzbekistan. Shit, I thought I know Uzbekistan is north of Turkmenistan. How does that happen? How are they touching each other? They should not be touching each other. Okay, okay, it is like on to the north, but also to the east also. So yeah, makes sense. That's fine. And then the capital of Afghanistan is Kabul, apparently. Then the flag would be this. And okay, okay. This okay, this okay, I'm going to be a bit there is snow here, so I think we can rule this one out. This one could be it. This one has rainy clouds in the background, and I do not think that is very often the case in Afghanistan and here also. So I'm going with this. Okay. Bro, what's your rating in chess? I am 800 rated. Yeah, I'm very bad at chess. You get any tips for beginner learning DSA from scratch? Yep. Uzbekistan, yep, I got it. GeoGuessr. Yeah, no, I'm not good at GeoGuessr, but I can play GeoGuessr. And for a beginner learning DSA, you can, I would say, Neat Code's roadmap is pretty fine, pretty cool. Neat Code's roadmap. This is pretty cool. You can do this. Neat Code's roadmap. That's cool. And here. I would go with this, which is wrong. This shit. Why is there ice? Is this has to be intentional? Ice in Afghanistan. Afghanistan has ice covered area. Shit, this is Afghanistan. Okay. Okay, apparently this is Afghanistan. This guy is also from Afghanistan, apparently. Do not mess with him. Shit, that is crazy. There is stuff like this in Afghanistan. And Citadel, Church, Old Donga Plantation, Big Ben. Nope, this is not Big Ben, at least. Yeah, yeah, that was just a guess. And which one is this? Ah, this one. And then population, spoken language. What do they speak? Hindi? I don't know. They do not speak Afghani, Urdu. What do they speak? Shit. Dari, Pashto. I've heard Pashto. Makes sense. I've heard Pashto. I don't know about Dari. How do they write these two languages? Something like this, I would suppose. That is correct. How many people are there? This has 10 million. Afghanistan would have more, quite a bit more. Afghani. Okay, this Kabul, Kandahar. I am just guessing. Shit. Okay. I can guess good. Exports, weapons. No. People. Okay. No. What does Afghanistan export? Oil. Okay. Computer. No. I'm just guessing at this point. And I don't really know. Animal produce, animal products. Yes, something like animal products. That is cool. And something else. What else does textile? Okay, that is wrong. So animal, that seems like right. Or okay, fruits and nuts is that thing at the top. Okay. Now the area, 650, 650,000 kilometers. And isn't NEET code paid? I mean, the course is, but the questions are not. And yeah, the questions are not. And whenever you see some topic, you can go to YouTube and watch his own explanation. There are videos for all of these, like this. There are videos and everything for all the questions. Which school? And for today, that would be the end of the stream.